Hi, everybody. Welcome to our first lesson in the grade 10 academic course. Today, we are doing a little review lesson where we're going to review a skill that we're going to need all throughout the course and that you'll just need in all your later math courses as well. That skill is solving equations. So we're going to just review some of the various strategies you learned in grade 9 that's going to help us out with us this year. So let's get started. First, let's just talk about what it actually means to solve an equation. So this isn't on your lesson sheet. You don't have to copy this down, just kind of talking it through together. When you solve an equation, you're finding the value of the unknown variable that makes the equation true. So consider a really simple equation I have for you guys right here. Just illustrate this idea. So consider the equation x plus 1 equals 5. So what that equation is asking is saying that some number times x, some number x plus 1 is equal to 5. So what is that number? What number plus 1 gives you 5? Well, I think everybody here could figure this out. It's 4. The solution to this equation is x equals 4. It's because 4 plus 1 is equal to 5. Now, most equations we're solving, it's hard to eyeball a solution like that. So we need some methods to help us out. So the first method we're going to review is called two-step solving, or at least that's what I call it. The key idea with this method is we're going to use opposite operations. So maybe that sounds familiar to you, and if not, that's okay. You may have called it something different, but everybody learned this in their grade 9 course, and some people even a bit before. We're going to solve a couple equations together using this method, and I'm going to show you guys how you can check an answer. And I'm going to show you the way I prefer to set these up. If you have just a different way of doing things, it's doing the same thing, but it just looks a bit different, that's totally fine. There's definitely more than one way to visualize and organize a problem. So let's solve this equation. 3 times what number? Subtract 8 equals 19. Well, I don't know about you, it's a bit early in the morning for me, so it's not entirely obvious. Let's go about solving this equation. So we want to get at the x. We want to get a final statement saying x equals something. So let's deal with the minus 8 and get rid of that. We use opposite operations. The opposite of subtracting 8 is adding 8. So I'm just going to add 8 to both sides, because whatever we do to one side, we have to do to the other side. Otherwise, they won't be equal anymore. So we added 8 to each side. And what are we left with? Well, negative 8 plus 8 is 0. And so like sometimes we'll just put a line to separate my steps here. So now I'm left with just 3x on the left. And on the right, 19 plus 8, that is 27. 3x equals 27. Now at this point, you may be able to solve this just mentally. But if you weren't sure, well, to get that x, right now we're multiplying by 3. So we want to divide both sides by 3. We divide by 3. Divide by 3, we get x equals to 9. And I like to put a box around my answer. And that's it. That's two-step solving, because it requires 2 steps, either adding or subtracting a number from both sides, and then dividing by whatever's in front of the x. So hopefully that method looks familiar to you. If it doesn't, well, we'll do another example. Let's try this one. 5x plus 19 equals 4. Again, not entirely obvious. Let's go about solving it. So we want to undo this positive 19. We want to kind of get at the x. So how do we deal with it? Well, the opposite of adding 19 is subtracting 19. So we'll do it from both sides. We're left with 5x. 19 minus 19 is 0. 4 subtract 19 is negative 15. So armed with a calculator, you guys can do anything. If you can do the mental math, that's great. And then 5 times what number is negative 15? For you, it might be obvious, but if you're not sure, divide by 5. Negative 15 divided by 5 is negative 3. The solution to this equation is x equals negative 3. Now, how can you check an answer? You probably learned a formal way of checking your answer. Ultimately, you could just check that in a calculator and say, well, what's 5 times negative 3 plus 19 equals, if it gives you 4, you did it right. We can do a bit of a formal check, and it's called a left side, right side check. And again, If you set these up a little bit differently than the way I'm going to, that's totally fine. But we make a little T-chart and we have left side, right side. What's on the left side of our equation? And we're checking part A here. On the left side of our equation, we had 3x minus 8. And on the right side of the equation, we had 19. So what we're going to do is we're just going to plug in what we think the value for x is and see if the left side and right side are equal. We're not resolving the equation here. We're evaluating each side at x equals 9. So we're going to plug in 9. 3 times 9 is 27. And 27 minus 8 is 19. Hey, and that equals the right-hand side. So I know that I did it right. So this is a formal way of showing that you understand that your solution is actually correct. So I may ask you once in a while to kind of show me a check for your answer. Something like this is totally fine. All right. So, that would be the introduction to solving equations you guys did in grade 9. And then you started adding kind of layers and solving more complex equations. So in these next examples, we're going to be solving by, I call it solving by balancing or collecting, because in these cases, they're not two-step equations. We have more things going on. So for example, if you look at A, we've got not only do we have a constant term on both sides of the equation, we now have an x term on both sides of the equation. So, but it's not so bad. What we're going to do is we're just going to collect all the x terms on one side of the equation and collect all the constant terms on another side and go from there, proceed as normal. So how does that work? And there are many ways to visualize this. So you don't have to use my way. So I like to just do what I did before. So I'd like to get all my x terms on the left. So how do I deal with this positive 3x? Well, the opposite of positive 3x is negative 3x. So I'm going to subtract 3x from each side. And what am I left with? Well, 5x minus 3x, that's 2x, minus 7 equals 11. And in this case, you'll notice that what I'm left with is just a two-step equation. So we can just solve this one like the previous two. Add 7 to each side. Put a little line. 2x equals 18. And if you weren't sure, you could divide by 2 and get x equals 9. But I think many of you guys should hopefully realize that 2 times 9 gives you 18. So yeah, x equals 9. Let's check our answer. I think this might be the last one we check in today's video lesson. So left side, right side. What's on the left side of our equation? 5x minus 7. So on the right side, 3x plus 11. Again, we're not resolving it. We're checking what the value is when we plug in 9 on both sides. So what happens when we plug in 9? We get 5 times 9, subtract 7. That's 45 minus 7. 45 minus 7 is 38. So it's my hope when I plug in 9 in the right side, I also get 38. So let's see. 3 times 9 plus 11. 3 times 9 is 27 plus 11. And look at that. 27 plus 11 is 38. So I'm completely confident that I did that right. Now, what you'll notice is that number 38 appears nowhere in the equation. And that's okay. It's totally fine as long as the left side and the right side give you the same value when you plug in your solution. Okay, so that was A. Let's look at B. B is a little bit different. Now we have 3x terms. So my advice would be, if you can collect like terms and simplify on one side of the equation first, do that. Because I'm looking at this left side of the equation, and I have a 6x and a 3x, and they're just sitting there. They're on the same side of the equation. I should add those together. 6x and 3x just make 9x. And at this point, with that one step, we've now reduced this equation to something like A. Now, you may be wondering or maybe worried, well, it's not, the x term is the second term on the right-hand side. It's 4 minus 10x. It's not the other way around. It doesn't matter. We can proceed as usual. Let's collect the x's on the left. The opposite of subtracting 10x is adding 10x. So I'll do that to each side. So again, I like to do this kind of vertically. Some of you guys may like to do it, may have done it horizontally in your previous grade. That's okay. So I get 19x plus 5 equals 4. Now it's a two-step equation. Subtract 5 from each side. 19x equals 4, subtract 5 is -1. And if I divide both sides by 19, we actually don't get a whole number like the previous examples. We'll get a decimal if we actually put in our calculators, but I would just say to you, just leave it as a fraction. -1 over 19. This is just the reality, is that, most equations actually won't have a nice answer. The ones your teachers cook up for you often do, or in your textbook. But yeah, in reality, the solution to equation will often be a fraction, and we just have to be okay with that. And leaving that as a fraction that's exact, that's great. Let's leave it as -1 over 19. And if you're concerned about fractions, we will need to deal with fractions every now and then throughout this course. But it's not like we'll have days and days of fraction operations. That said, though, if you're ever unsure how to do an operation with fractions, adding fractions, multiplying fractions, etc., it's not that bad to learn. If we're not in class and I'm not available to help you, you could watch a quick 2-minute YouTube video on how to add fractions or Google it. They're very simple rules, and we shouldn't be overwhelmed by that. Of course, these days our calculators can also do fraction operations. But I digress a little bit. 2 examples where we collect like terms if possible, and then we group the x terms on one side, we make it into a 2-step equation. So let's keep going. Some more complicated equations will need further simplifying, like equations involving the distributive law. So, So here's the first example we're going to solve. And in this case, what we're going to do with this equation that involves some brackets is we're going to apply our distributive law and then proceed as usual. So we're going to turn this more complicated equation into one that we've solved before. So in grade 9, you guys learned the distributive law. In this case, when we're multiplying some stuff in a bracket by something out front, it's as if we're multiplying every single thing in these brackets by what's out front. So the first bracket, everything by 3. So 3x plus 3. And then on the right side, we get 9 times x, and 9 times -3 is -27. And it's my hope that you don't need me to keep going from here. We've done several examples now of solving by balancing, and in this case, we just finish it off. So we'll move a little bit quicker through these guys. So we'll subtract 9x from each side. We get -6x. We still have our plus 3 and -27. Now a 2-step equation, we'll subtract 3 from each side. We're left with -6x. -27 subtract 3 is -30. And then finally, dividing by -6. Don't forget to divide by the entire number, so including the sign, -6. -30 divided by -6 is 5. +5. Nice round number. So with that, just one extra step of applying the distributive law, it turns it into something we can do and that we've done before, and we finish it off. Now, just want to say, in this first step here, I subtracted 9 from both sides. If you wanted to group the x's on the right, you could do that. You could subtract 3x from both sides. But in my experience, a lot of students just want, something that works. They can repeat. So I often collect my x terms on the left. So we applied the distributive law. We proceeded as usual. So now that we've talked about how solving more complex problems involving brackets, distributive law, proceed as normal. The last type of equation that you solved in your grade 9 course was how to solve equations with fractions as the coefficients. So, and I put a gasp there because I'm sure I'm positive that some of you guys, when you see a fraction or hear the word fractions, you kind of panic a bit because you're not great working with them. But as I said, you can get good working with them. If you're unsure, again, reach out to me. Go on Google, watch a couple-minute video. There's lots of resources to help you out. Now, we're not actually going to group, like for example, in our previous question, we might have subtracted 2/3 x from each side here, and you could definitely do that. But the easier way to do problems with fractions is to clear the fractions. We multiply the whole equation by a lowest common denominator. And what's that is going to do is it's going to turn this equation that has fractions into one that doesn't. And personally, I would rather solve an equation with no fractions than an equation that has fractions. So how do we do that? Well, in this case, you look at the coefficients that are fractions. And here we have 1/2 and 2/3. And we think, well, what is the lowest common denominator for those numbers 2 and 3? Now, hopefully, most of you guys can recognize it's 6. And if you're unsure, multiplying the denominators together always gives you one that works. And in this case, it just so happens to be the lowest one. We're going to multiply both sides of the equation by 6. So what does that look like? I'm actually just gonna rewrite the whole equation just with this added step of multiplying both sides by 6. All right, so I've multiplied both sides by 6. I did the same thing to both sides, so the equation is still balanced. But watch what happens. So let's use the distributive law, and we'll do 6 times 1/2. So that's just like 1/2 of 6. That's 3x. No more fractions. So just to the side there as well. If the reality is, if you're taking the grade 10 academic course, I would expect 6 times 1/2 to be something not overwhelming to you. There are various ways mentally that we could go at that. So 6 times 1/2, you could, if we wanted to just purely use the rules for multiplying fractions, I could write that as 6/1 times 1/2. And when you multiply fractions, you multiply the tops and bottoms. 6, 2 on the bottom, 6 divided by 2 is 3. But I would expect you guys to be able to do that quickly. A shortcut would also be to just do, when you're multiplying a whole number by a fraction, is just to do the whole number times the top divided by the bottom. 6 times 1 is 6, divided by 2 is 3. And I think that is reasonable for me to expect of you coming into the grade 10 academic course, since you've chosen to take this course. We can't spend all of our time agonizing over every single fraction operation. We might move a little quicker through those. Again, if you do need help with the fraction stuff, please reach out. 6 times 5, 30. So no more fractions on the left, and look what happens on the right. 6 times 2/3. What's 2/3 of 6? Well, it's 4. We're left with 4x. How'd I get that? Again, and just for this one, I'll show, so if we do 6/1 times 2/3, multiply the tops, 12, multiply the bottoms, 3, we get 4. Or you could just do 6 times 2 is 12, divided by 3 is 4. Or I don't think it unreasonable. Many of you guys could probably just visualize 2/3 of 6 and be like, okay, yeah, it's 4. And 6 times 3 is 18. So we apply the distributive law on this side. And we've turned that messy equation with fractions into one with no fractions, and life is good. Let's proceed like we normally do. Collect the x's on the left. By subtracting 4x, I get negative x. So that's like negative 1x plus 30 equals 18. negative x equals negative 12. And at this point, to get x by itself, we just change the signs on each side or divide by negative 1, whatever you feel comfortable doing. But I'm just going to change the sign. So if negative x is negative 12, then x is equal to 12. And we've got it. So any equation that we have with fractions, no problem. Clear the fractions by multiplying by lowest common denominator. All right, guys, I have a couple here that mix in all the different methods. So what would be great is if you paused the video and at least gave these a try. When you're ready to see how you did, you can unpause the video. Or if you get stuck, then you can just pause.
Miss Fleming, phone call line 101. Miss Fleming, phone call line 101.
It's the beauty of recording lessons in school. Again, if you're stuck, just unpause the video. And if you're really struggling and would just rather copy down the solutions with me, that's okay too. But we definitely want to get you to becoming a bit more independent with these. So if you're, again, pause the video, try these, but if you're ready to go, you can unpause and let's solve these guys. So I'm looking at equation C, and I've got some brackets. So I see brackets, I think, okay, let's use the distributive law and multiply out. So I have 5x plus 5, and that's everything that was in the bracket. I don't multiply the 2 by 5.
Miss Foxy, phone call line 101. Miss Foxy, phone call line 101.
And that's all I'm going to do for that first line. And now I see, well, on my left side here, I'm always thinking of collecting and making things simple. I've got 5 and 2. They're on the same side of the equation. Well, 5 plus 2 is 7. So why am I writing plus 5 and plus 2 when I can make that more simple? That's equal to 7. And look, after those two very simple steps, I now have an equation that I can solve by collecting the x's on one side. And this one actually works out really nice because look, if you subtract 4x from each side, 5 minus 4 is exactly 1. We get just x plus 7 equals negative 1. Subtract 7 from both sides. Negative 1 subtract 7 is negative 8. And guys, we got it. So that problem had it all except for fractions. Let's do one more with fractions. So if you try D, the lowest common denominator for this problem, the best one to use is 12. So we'll multiply both sides of the equation by 12. So as I'm writing this out, just want to again remind you that you may have your own way of kind of organizing things and doing things from your grade 9 course that is kind of similar to what I'm doing and visualizing here, but it might just be the way you're comfortable doing it. You don't have to do it my way. You can do it your way. So now that we've set that up, let's do the multiplications. So 12 times 4, 48. 48 divided by 3, 16. 16x. 12 times negative 2 is negative 24. 1/4 of 12, that's a bit easier with mental math, but you can just do 12 times 1 divided by 4. Or just use your calculator, to be honest. And 12 times 11 is 132. So bigger numbers, but the steps are the same. Let's take 3x away from each side. 13x minus 24 equals 132. Add 24 to each side. 13x equals 156. And if you divide both sides by 13, last time I checked, that gave you 12. X equals 12. We got it, guys. So that problem had it all. And the examples we've done here, it's impossible to cover every single type and every single way an equation can be kind of rearranged with an x here or an x there. But these underlying principles can help you solve any equation. And we have got a lot in the books, and we're going to practice a lot as well. So what's up next? So in our next lesson, we're going to take a pause on solving equations. We're going to review what a relation is, and specifically what a linear relation is. And after that, we're going to apply the solving equation skill with the linear relation skill, and we're going to start our new unit on linear systems. So it should be fun. But for now, that's it for this lesson, guys. Hope you guys are staying well. Have a great day, and we'll see you soon.